Okay, let's investigate why equilibrium and the intersection of marginal cost and marginal benefit are equivalent. In order to do that, we need to somehow connect the demand curve to the marginal benefit curve and the supply curve to the marginal cost curve. Now, how do we do that? Well, let's start with connecting demand to marginal benefit. So we have a demand curve that we're all familiar with, okay, and that's if it satisfies the law of demand, which we can make the assumption it does, it's going to be downward sloping. Okay, now we construct this curve using the law of demand. We construct this curve by saying that if prices are at P1, people will purchase Q1 units of the product. If you lower the price to P2, people will purchase Q2 units of the product. Okay, so prices and quantity demanded are inversely related, okay? But if you noticed how I made that argument, I said basically pick a price, how much will people buy? Pick another price, how much will people buy? Now let's think about how that relates to marginal benefit. In terms of marginal benefit, okay, we say that if we're presented with Q1 units, what would it take for me to buy that Q1th unit? So let's just say this Q1th unit is 2 hot dogs at the local county fair or something like that. So Q1 equals 2 hot dogs. So I've already eaten 1 hot dog. How much am I willing to pay for the second hot dog? In other words, what does the price have to be to give me the incentive to purchase that second hot dog? Well, the price can be no higher than the amount of enjoyment I get from that second hot dog. In other words, the price can be no higher than the amount of benefit I get from that second hot dog. As long as the price is no higher than that, I will buy that second hot dog. Let's just say that price is equal to P1. So if the price of the hot dog is P1, I will buy that second hot dog. If I flip that around, that means that the amount of enjoyment I get out of that hot dog must be at least the price level of the product, right? Therefore, I will buy that second hot dog. Now, let's say I've already eaten 2 hot dogs. I purchase a third hot dog, okay, and I eat that. What will give me the incentive to purchase a 4th hot dog? So say Q2 equals 4 hot dogs. I've already consumed 3 of them. Well, again, I will buy that 4th hot dog if the price is low enough for me to have the incentive to buy that hot dog. In other words, if the price is no more than the enjoyment I get from that 4th hot dog. Well, I've already eaten 3, so the amount of enjoyment I'm going to get off the 4th one is going to be less than I got off the 3rd one, and that's going to be less than the amount of enjoyment I get off the 2nd one, which is less than the amount of enjoyment I got off the 1st one. Okay? So I'm not willing to pay as much for it. I'm only willing to pay P2 for that 4th hot dog. But if the price is no higher than P2, I will indeed purchase that 4th hot dog. Meaning what? Meaning that distance there must be equal, or at least in terms of price, equal to the amount of enjoyment I get off that 4th hot dog. So the amount of enjoyment I get off the second hot dog is measured by the price I'm willing to pay for it, and therefore that is also the amount of benefit I get from it. the price of the fourth hot dog can be no more than the amount of enjoyment I get off it. Therefore, the price and the marginal benefit of that hot dog are equivalent. In other words, I get exactly the same curve, only we call this the marginal benefit curve. But as you can see, in looking at the two cases, we constructed the demand curve by saying, okay, pick a price level. How much will people buy at that price level? Here we're saying pick a quantity. What will give the incentive? What will give people the incentive to buy that last unit? So you're looking at exactly the same concept. You're just looking at it from the horizontal axis here, and you're looking at it from the vertical axis here. You put the two together, then it must be the case that demand is equivalent to marginal benefit. You're just looking at the two from different axes. Now let's flip this over. Or not flip it over. Let's move on to marginal cost and supply. So we know what a supply curve looks like, typically. Okay, a supply curve is upward sloping. Now, how do we get that supply curve? Well, just like demand, just like mapping out a demand curve, what we do is we say, okay, at a price of P1, how much product will firms be willing to put on store shelves? Well, they'll be willing to put on Q1 units. At a price of P2, well, they're getting more for each unit, and therefore, ceteris paribus, holding all else constant, they're willing to put more stuff on store shelves. Okay? Now, if that's the case, then let's think about it from a cost perspective. So from a cost perspective, the equivalent argument of, okay, at a price of P1, firms are willing to put Q1 units on store shelves. At a price of P2, however, because it's a lot higher, holding everything else constant, they're willing to put more product on the shelf just because they're able to get more for it. So that makes sense. But in a marginal cost perspective, the equivalent analysis would be, in order to get a firm to put that last unit on the store shelf, whatever that is, the 100th unit, the 150th unit, whatever, how much do they need to get for that unit in order to have the incentive to put that unit on a store shelf? Well, they have to get at least what it costs to produce that unit, right? And that's the definition of marginal cost. So they have to get a price that is at least as much as the cost of putting that unit on the shelf. Okay? In order for them to put the Q2nd unit on the shelf, okay, a much higher quantity, because of fixed factors of production, something that was explained earlier, they're going to need to get a higher price for that last unit in order to have the incentive to put it on a store shelf. Okay? Remember what fixed factors of production says. It says that if firms in the short run want to increase their level of output, the only thing they can do is cram more workers in a confined area. Well, if you cram more workers in a confined area, all the workers get less and less efficient, meaning that the cost to produce the last unit must be going up. Okay? So, if that's the case, then, in order for a firm to move from Q1 units to Q2 units, they have to put more people in a confined area. When they put more labor into this confined area, the cost of producing that unit goes up, meaning that they have to get more for it, say P2. And that maps out the marginal cost curve. Okay? In other words, the cost of producing that last unit, the Q first unit, is that much. The cost of producing that unit, say this was the 100th unit and this is the 200th unit, the cost of producing that unit must be that much. Okay? And in order for them to put that unit on the store shelf, they have to get at least cover the cost of that unit. So they're going to want P2 for it. In other words, if you put the two together, it must be the case that supply is equivalent to marginal cost. Now, that said, if we put the two together, then we get supply, we get demand, and because they're both equivalent to marginal cost and marginal benefit, the equilibrium amounts you get must have an equivalent but opposite argument. Okay? In other words, in order to determine, let me go back here. If you remember, going back to demand, we said that in order to argue the existence of demand using the law of demand, we set a price, and that price determines however much product people want. In order to determine marginal benefit, we ask ourselves, okay, what will it take for someone to consume that last unit? So we're looking at it from the horizontal axis. Well, as long as they pay no more for that unit than the benefit they get from that unit, they will purchase that unit. So Q determines P. Up here, P determines Q. We go to supply, you have basically the same argument. In mapping out the supply curve, we said, okay, at this price, how much will firms be willing to put on a store shelf? At this price, how much will firms be willing to put on a store shelf? On the flip side with marginal cost, we said, okay, to get a firm to put this much product on the shelf, how much do they have to get for that last unit? Well, at least what it cost them to produce it. In order for a firm to put this much product on the store shelf, what do they need to get for that last unit in order to have the incentive to do that? Well, at least what it cost them to produce that unit. So up here under supply, we're saying set a price that determines an output level. Here we're saying set an output level. What does the price need to be for the firm to put that output level on a store shelf? We put everything together, we get this. Now the question is, why is P star equilibrium price? Well, P star is equilibrium price because if price was at P1, we would have a shortage of the product, and that's not efficient, right? A firm can raise the price of the product, increase quantity supplied, and still sell everything they put on the store shelf. So why wouldn't a firm want to increase price, increase output, and still sell everything you have? It would be dumb not to. On the flip side, this shortage means that people are standing in line waiting for the product. That is inefficient. That is a waste of people's time. They can be doing other things with their time instead of waiting in line for a product to be restocked on the shelf. In other words, the incentive here is for prices to rise. If prices are really high, though, we get a surplus of the product. Okay, that's surplus there. Well, this is also inefficient because a surplus means product's going to go bad as it sits on the shelf. Furthermore, inventories cost money. Why would a firm want to have an inventory if they don't have to? In other words, if they find that they've priced a product too high and it causes a surplus, guess what? They're going to want to lower the price in order to get rid of that surplus. In other words, P star is equilibrium price based on the supply and demand argument. In other words, looking at it from the angle of prices. Question is, why is Q star equilibrium quantity? That's where we break out I'm just going to here separate out marginal cost and marginal benefit just so it's clear. Marginal benefit. So why is Q star equilibrium quantity? Well, because if too much output is produced, say Q2 units, well, the cost of producing that unit is this much, but the benefit people get from that unit is only this much. Well, it obviously then costs society a lot more to make that last unit than the benefit they get from that last unit. So what does society want from that unit? They want fewer units. Now let's assume price is really low. Let's assume let's assume output is really low. So there's only Q1 units on store shelves. Well, if there's only this few units on store shelves, people get that much benefit from that last unit that was put on the store shelf. But it only costs society this much to make that unit. So the benefit society gets from that unit far exceeds the cost to society of making that unit, so society naturally wants more units. Q star must then be equilibrium quantity. That's why the two concepts of supply and demand and marginal cost and marginal benefit are actually equivalent concepts. You're just viewing the entire analysis from a different perspective. You're viewing supply and demand from the vertical axis, set a price, what Q results, and you're analyzing marginal cost and marginal benefit from the horizontal axis. Given that Q, what has to be the case? And that's why the two are equivalent.